Welcome everyone to our third Thursday Telecon for March 2019. It's actually the fourth Thursday of the month. We got a little bit of a delay, but that's okay. Everybody's here. I'm Dan Zevin from UC Berkeley Space Sciences Laboratory. And today, as always, we have Dr. Andrew Westphal, PI from Stardust at Home and the NASA Stardust mission, who's going to be bringing us up to speed on the research and the project in general. But we also have Mr. Robert Lettieri from the Space Sciences Lab. He handles a lot of the back room stuff with regard to...
Back room?
Yeah.
Back end. Back end. Not back room.
Yeah, well, a little bit of both, I think. But yeah, he helps keep the system working. And lately there have been a few issues. So Robert, maybe you could just give everyone an update on why they might be experiencing some issues with the Stardust at Home interface.
I don't have any answers as to why, but there definitely has been things going on, and I'm not sure what's been causing them. So like I was telling Mike before, that the way the system is set up is there's two machines. One is the web server that serves, the web server serves Stardust at Home, the forum, and foils and aerogel. All the web stuff happens on one computer, and then there's a database server that does the database for Stardust at Home, aerogel, foils, and the forum, and that runs on a separate machine. And something is occurring between those two machines. I don't know what it is. I don't know whether it is a lot of extra web access, so some I don't know, bad player trying to sign into the forum. That happens a lot, where we get people just continually registering for the forum. We get something like, I don't know, 7 to 10 registrations a day that are just spam, because they all occur at the same time. So, you know, nobody registers for the forum, you know, or 7 people don't register for the forum within a minute. So those types of things could be causing the web server to crash, causing the database server to crash. There's no information in the logs as to what's going on. So I've been monitoring it. I thought it was under control. We had a lot of trouble at the beginning of February or end of January, and I thought it settled down, but it seems to have reared its head again, and I'm not sure what it is. I'm going to purchase some software as soon as Andrew approves it to monitor the servers remotely and record some history of what happened, so maybe we can debug what goes on. Also, I'm going to put together a couple of virtual machines that will allow me to create a cleaner system OS to see if there's any other, because these machines are kind of old and they've got a lot of history in them as far as updates and versions of Stardust. You know, we're on the 7th version of Stardust, and these machines have run probably 5 of them. So there's a bit of history there that should be cleaned out. So I'm going to try making a clean system and see what occurs. I think that's it for me. Any questions?
Do you want Dusters to continue to report issues? Does that help?
Absolutely. I appreciate getting my 6:30 a.m. emails from Mike who says, hey, the site's down. So because like I told him before, this morning I checked around 5:30 our time and it was working. So I just don't know what's causing it to seize, and I don't know which side of the equation. I've been thinking that it's the database server, but now it may have been the web server machine that's giving us problems. So I'm going to debug, and I'll probably put something together in the next week or two, a clean new machine, and I'll probably have you guys, I'll send out a note to have you guys take a look at it to make sure it's working. And then we'll have some downtime where I have to migrate the data and the stuff to the new server. So that's where we're at.
All right, well, yeah, let's see if there's any questions. Mike in Detroit, anything regarding this issue for Robert you want to ask or notify him about?
He's been good.
Oh, you're muted.
Can't hear you.
Sorry about that. I forgot I was muted. No. That's no. I think he's on top of it, and he's given as much explanation as I can my limited expertise can handle, so that's fine.
Okay, and we're really glad to have you back with us again, Mike, one of our diehard regulars. So thank you. And another diehard regular, Augusto in Palermo, Italy. You've been
back. Do you hear me?
Yeah, we can see you, Tom. I'm going to say hello to Augusto first. Any questions for Robert? I know you've experienced some of these problems too, and we appreciate your reports.
I have noted that the problems are in specific period of time in the day, and after run quite normal.
What time of day?
Dunque. 8
p.m. p.m. in the a.m.
If I work before my 5 p.m., I don't have many problems. About 7 p.m. until 8 p.m., big problem. I guessed that where the flash, the flussi, come si dice? No. The flow of the web, because no.
Do you mean that maybe there's a lot of traffic on the transatlantic connection?
It's possible. It is.
Yeah.
I believe it, because the coincidence is with the hour in which you usually go to the office in the morning.
Right.
Well, the minute you notice something again, send Robert an email, and
you can send me an email.
What you're noticing and what time it happened, and then I'll let Robert figure out what time you're referring to. And Tom Yonke, you're in St. Louis. Thanks for being with us again as well. So we were talking about people having experiences, bad experiences trying to log on, or other issues with dusting, and Robert just gave an update on what he thinks the problem might be, and
I've had lots of
that he doesn't know. But yeah, if you continue to experience problems, do let Robert know, okay?
I log on, then I'm blocked, then I'm back on, then I'm blocked. It could be in the morning, it can be in the afternoon, it can be at night. But I don't give up, you know. If it won't, I just come back 5, 10, 15 minutes later, and often I can log on. For a little while anyway.
The system kicks you off?
Yeah, it just sign comes up that I can't log on to that site. It won't accept my signal. I'm not sure those are the right words.
Yeah, and I'm not sure that there's anything I'm doing about that that's happening from this end.
Well, I'll make a note of it the next time and put it in words and send it to you.
Yeah, time is critical, because that way I can look at logs, which I haven't really found anything in, but to see if there's anything that happens at those times to help me debug what's going on.
Okay.
All right. Well, thank you, everyone, for those reports. We don't like it when we're having issues with the system, because it does mean you have problems dusting, and that's what we want you to do. So thankfully, we have Robert to look into it. Hopefully, we'll have this figured out soon, especially if we get some new equipment. That probably might be the trick. Anyway, let's get into some science. Thanks again, Robert. But let's turn this now over to Andrew, our featured presenter, as usual. You just got back from an important conference, did you not, Andrew?
I did. So I just got back from the Lunar and Planetary Science Conference. That's why we had a delay last week, because it turned out that the time for the for our Third Thursday conference was right in the middle of the most important session at the conference for our group. And so that's why we decided to postpone for a week. And thank you everyone for your flexibility. Yeah, so let me give some highlights about LPSC in a minute. But first, I want to give an update about our project. So I guess it was, let me think, 2 or 3 weeks ago, I forget exactly the date, we attempted to analyze 4 interstellar candidates these are tracks in aerogel on the new cosmic beamline at the Advanced Light Source at LBL. And so I think we've talked about that before in Third Thursday Telecons. This is a new beamline that is practically unique in the world. So we're very fortunate to have time on it. And but it is a new beamline, and it still has some bugs that occasionally come up. And unfortunately, one came up for us. We were able to do analyses in principle, but it turned out that the energy range on the beamline was such that we could not get to the magnesium edge, which is where we wanted to start the analyses. And so what our order of business is to look at aluminum and magnesium first at the candidates, because that's the first screening to eliminate the possibility of spacecraft in the track. And unfortunately, the beamline was not behaving properly, and we couldn't get to that energy. We could get to iron in principle, but which is lower energy, but we could not get up to aluminum and magnesium. And so we made a command decision that, because every time you handle the samples, you risk that poses some risk of losing the samples, especially in a new situation. We decided that we would be cautious and not analyze those on this run. So we have been promised that we will get more time. We don't have a schedule yet for when it's going to happen, but we will be able to get to these after they fix this problem. So, but the cool thing is that this was work principally by Anna Butterworth. We used a new feature of the beamline called tychography. So it's a strange word. Do I have a chat? Is there a chat over here? Yes, there is a chat. So I'm going to spell it out. It's got a silent P. So it looks like this. And can everybody see that? So I'm actually not even sure what the Greek. It's clear. It's obviously a Greek root, but I'm not sure where it comes from.
Yeah.
But anyway, it's a capability, new capability on this beamline, and it uses phase contrast to get really impressive spatial resolution. So we got spectacular data from some particles that have been studied by the community for years called GEMS. These are glass embedded with metals and sulfides that are commonly found in interplanetary dust particles. And they have an enigmatic origin. They're highly controversial in the field. Many people think that they originate in the solar system, but there are people who think that they're actually interstellar in origin. We don't know. So they're mysterious. And we have now spectacular images of these particles. And if I can remember to do it next Thursday, Third Thursday Telecon, I will have some images. I only just saw them myself a few minutes ago. Anna showed me some of these images, but these are spectacular and they're weird on a small scale, really bizarre. And so, so this was really a great success. It was not an advance on the Stardust project, but it could potentially be important for our understanding of these particles. And so that was, I think that was the news on the synchrotron analyses. Let's see. So let me just talk a little bit about the LPSC. It was a great LPSC, one of the best I've been to recently. Let's see. One thing I'll mention was, so one of the things that happens at these conferences is that you see all your colleagues, or many of them, most of them. So I saw both Rhonda Stroud and Brad DeGregorio there. Rhonda is coming out in a couple of weeks, and we're going to talk more about craters in foils. I'm preparing a new set of foils for them to scan and make imagery of, and we should be able to get that imagery to put onto foils at home. And Brad has some interesting candidates that he wanted to talk about, and we haven't we haven't connected, but I think that's something that Rhonda and I will talk about when she's out here. She's out, I think maybe both of them actually are coming out to the Advanced Light Source to do some infrared work at the ALS. So stay tuned. We may have some interesting new candidates to talk about from the foils. Okay, so let me just give some highlights from LPSC. So there were 3 special sessions at LPSC, all on spacecraft which have visited new bodies in the solar systems. So the first one was about the New Horizons mission to, which of course went to Pluto, flew past Pluto and the Pluton, Charon, etc. system, and collected spectacular images, amazing images of Pluto, with bizarre features that people still don't really understand in many cases. But it was, I guess, it was in January. Was it January? Was it on January 1st? Anyway, I forget what day it was, but it flew past the most distant object ever visited by a spacecraft, called Ultima Thule. And you probably have seen pictures in the newspaper about it. It looks like a snowman. And it is a contact binary. So it's 2 objects, smaller object and a bigger object. And the first images make it look like this, 2 spheres in contact. But it turns out that they're actually, especially the bigger one, is actually apparently flat. It's like a plate. And the other one is also not spherical. And so they're contact binary rotating like this. There was an entire session of talks, 15-minute talks, all morning about observations of Ultima Thule. And I think for me the most interesting part is that it really, 2 things. One is that these objects are probably very common in the Kuiper belt, these kind of contact binaries. And in fact, they're probably the reason that several comets that we have visited, especially most spectacularly the one visited by the European Rosetta mission to comet CG, Churyumov-Gerasimenko. It's also called 67P. It's also a contact binary. And 67P looks like a rubber duck. Your mind always goes to these, familiar kinds of shapes. And so it probably, 67P probably formed in the Kuiper belt in the same way that Ultima Thule did. And this solves a long-standing problem in planetary science, which is, how do you build planets? How do you go from dust, interstellar, tiny little rocks that are less than a micron in size, how do you go from that to building planets? And the problem is that it's easy to get little particles to stick with each other. So micron-sized dust, if they come in contact, they'll never come apart. They will stick. And so you can build up objects this way up to about the roughly centimeter to meter size. Above that size, when objects get when they hit each other, even very slowly, instead of merging, these objects will shatter. And so it's a long-standing problem. How do you get past that so-called meter barrier to get to kilometer-sized objects? Once you're up to kilometer-sized objects, it's no problem to build planets because gravity takes over. And now when things collide, they may shatter, but then gravity collects them all again. So you can build larger and larger objects. But getting past this meter barrier has always been a problem. So there's really compelling evidence from Ultima Thule that this is an object which formed from kilometer scale kinds of planetesimals that came together to form this object. And they even have sort of geological maps of this thing which show this. And probably the answer is that eddies, there are several mechanisms, but eddies in the protoplanetary disk collected pebble-sized objects, so things like the centimeter scale. And then these clouds of centimeter objects were gravitationally unstable and collapsed directly to kilometer-sized or larger objects. And so that got past the that's the way that nature got past or jumped over the meter scale problem, the meter barrier. And so this is very exciting. And the other thing that was really interesting was that there are very, very few craters, it turns out, on Ultima Thule. And it's almost completely devoid of any impacts. So what that tells us is that it tells us something about the density of small objects in the outer solar system. And this may be connected exactly with the same thing, that, you know, if you have a distribution of particles that go all the way down to centimeter size or meter size or 10 meter size, then if these formed in the solar system, then they should be common and they should make impacts on Ultima Thule. The fact that you don't see them maybe says that they aren't there, and that's consistent with this picture that nature jumped over this meter barrier all the way up to the kilometer scale barrier size. So so it's really cool to see this, you know, and unexpected to see these results. You know, who ordered that? And so very fun and exciting. So please interrupt me with any questions if you have any. Maybe I should pause and ask. Not at the moment. Okay, so I'll go on. So there were two other sessions that were really quite related to each other from two missions, OSIRIS-REx, which my daughter Laura and I went to go see the launch, was it a year and a half ago or 2 years ago at Kennedy. And so it's now rendezvoused with this asteroid Bennu, and then Hayabusa 2, which is a Japanese mission with a similar goal to rendezvous with an asteroid and collect a sample. In both cases, they will collect samples and then return them to Earth for analyses. And they'll be both coming back, I forget the dates, but something like 2023 or 2024. Somebody can correct me. I don't remember exactly the dates, but anyway. So they're both at these asteroids. The asteroids are different in size by about a factor of 2, but they look very similar. They look like tops. They look, from the side, they look like a diamond. And so it's really interesting that these rubble pile kinds of asteroids, that is, they're not coherent rocks. They're piles of smaller objects, some of which are giant boulders. I mean, 10-meter size large objects, rocks, but that they seem to very naturally assume this sort of diamond-like shape, which is interesting. And there were some talks about how that might happen. But the big exciting thing about the observation of Bennu is, so OSIRIS-REx was taking lots of pictures. Both of them take lots of pictures. And some of them are for doing science, and some of them are for doing navigation, just so that they can know where they are with respect to the asteroid, because they don't want to crash into it by accident. So OSIRIS-REx was taking some pictures of the limb of Bennu. So the limb means there's a picture with the asteroid and then space. So you're looking at the side of the asteroid. And what did they see? They saw rocks coming off of the asteroid. So it's an active object. It's actually throwing off rocks into space. It's shedding rocks. And this is a huge surprise. And it's not clear what the mechanism is. It must be that there are ices or something that are volatilizing, and then throwing rocks off in a kind of explosive way. But you know, that implies that these objects, or at least for Bennu, may not have been in the orbit it's in for very long, because otherwise it would have completely evaporated. And so anyway, huge surprise and just very interesting and unclear what it means. And so far, Hayabusa 2 has not seen a similar kind of activity on Ryugu, and they would have if it were happening. So maybe Ryugu is a older object, or a different object, or who knows? You know, so we'll be getting samples back into our laboratories, and that may tell us something about about this phenomenon, or it might not. We don't know. So, so it's very exciting. Let's see. So what else? We met some collaborators. We're working together on putting up a collector, interstellar dust collector that's 10 times the size of the Stardust collector, to go on to something called the Deep Space Gateway. So this is like a space station that's going to be in orbit around the moon. And a small space station. It will be occupied by people only 1 month out of the year. And so 11 months out of the year, it will be available as a platform for putting up scientific payloads. And so we're talking about putting up collectors for interstellar and interplanetary dust using aerogel, using other collecting media, including silicon nitride windows on top of ultra-pure collectors like the Genesis mission had on board. So it's something we're investigating. NASA is actually doing some building mock-ups. There's actually been an astronaut training session with one of the collectors. This is something that one wants to do, but it's highly uncertain whether it will actually happen. The political winds can change, and so this is a project which may happen, may not happen. It's unclear, but it's important to be prepared for the possibility if it does happen. And so we also met with Steve Jones, who was at LPSC. Steve is the hero of the Stardust mission because he made the Stardust aerogel. And we talked a bit about how to make aerogels, new aerogels that do not have the all of the features that Stardust at home dusters are very familiar with, the cracks and the inclusions and the surface features and the long trains of chevrons and so on. And he has some ideas about how we might be able to make aerogels that will be easier to scan in the future. No matter what, this is something that would probably not happen for at least 5 years, maybe longer. So we don't know. It's unclear what the timescale is for this, but it is something NASA is actively pursuing. Let's see. Sometimes it's really nice to go to this conference and go to sessions that are completely unfamiliar. So I don't know a thing about Venus, but I dropped in with my daughter. My younger daughter actually was at LPSC for a couple of days because she contributed to our measurement that we just made of manganese in the solar wind, and but she and I dropped in on the session on Venus, and one of the talks was really interesting. It was about climate change on Venus. So Venus is an interesting object because it's so similar to Earth in many ways. One of the things that we're pretty confident about is that it used to have, at least it had a lot of hydrogen at one time in its past, which is gone. And the evidence for this is that there's a huge amount of excess deuterium in Venus, which implies that there was a huge amount of evaporation of hydrogen, loss of hydrogen, perhaps related to the fact that Venus doesn't happen to have a magnetic field. And so it can't trap particles that want to escape into space the way that Earth can. I'm not an expert in this at all, so I may not be getting this exactly right, what the current thinking is. At any rate, there is apparently evidence that about 700 million years ago, that Venus went through an enormous heating event, which led to what it is now, surface temperature of, 450 degrees C or something like that. It's like the temperature of your self-cleaning oven, on the surface. But before 700 million years ago, Venus may have had a very Earth-like environment, a temperate environment like Earth's. And that something happened which caused it to go into this runaway climate catastrophe. And one of the speculations is that it could have been a volcanic eruption like we've seen on Earth periodically. These, like, for example, the Deccan traps which are these big lava flows, gigantic lava flows in India, and there have been several others. So the speculation is that it could have been one of these gigantic volcanic flows on Venus, which triggered it. But it is something that's most people don't realize is that you might think, well, the reason Venus is so hot is because it's closer to the sun, and so it absorbs sunlight, much more sunlight than the Earth does. So of course it's hotter, but actually it's not true at all. Venus's albedo is much higher than that of the Earth. So Venus, even though it's closer to the sun, actually absorbs less sunlight, less power from the sun than the Earth does. The entire reason that it's so hot is because it has such a strong greenhouse in its atmosphere, and so nobody thinks that we're in danger of turning into Venus, but it's a sobering reminder of the power of atmospheric greenhouses. I think that's about it. There were Zach Gainsforth gave a really great talk about GEMS at this session, and got a lot of compliments about it. Dave Frank, who is a colleague at Hawaii, gave an interesting talk about cometary particles that we've studied that had come from a kind of unexpected asteroidal source. It's a little speculative, but the evidence is pretty strong. And so I think that's all. I mean, I could go on and on probably, but it was a very stimulating conference. And so are there any questions?
Yeah, that was fascinating. Quite a tour of the solar system.
Yeah, no, it's a fantastic time.
Yeah, you could put together a wonderful little PBS special, I think.
That's a great idea, actually. Yeah, right, right.
Visiting these wonderful worlds. Yeah, let's see if there's any questions from the group.
No, I have one regarding the potentially new aerogels. Mm-hmm. Any of those new candidates have the capability of visibly capturing the smaller ISPs, than our current aerogel?
I'm not sure I understood your question.
Well, the current aerogel, the finer particles.
Oh, yes. Oh, I see. Yes.
Weren't visible.
The really tiny ones, right? Yeah. Right. Which we see in the foils, and we are completely invisible in the aerogel. That's a great question. The answer is I don't know. So we're thinking about one of the things we're talking about is to use in addition to silica aerogel, is to use. It turns out that there is also a transparent aerogel that's made of tantalum oxide. So it's a tantala aerogel. I have zero experience with it. The potential advantage of it is that it isn't made of silicon. That's the main attraction, because the problem is that we can't really. It's very difficult to analyze silicon in particles which have been captured in silica aerogel, because you're just overwhelmed by the silicon background, the capture medium. And so having something which is not silicon, not one of the major elements in nature, would be an advantage. But on the other hand, it may present new challenges, because tantalum is element 73. So it's got lots of X-ray absorption lines and lots of X-ray fluorescence and stuff. So it may be hard to analyze in the synchrotron. This is more detail than you want to know. But the question, and it's an excellent question, I hadn't even thought of that. It's possible that these really tiny particles might be more visible in the tantalum. So actually, it's a great idea. We should do some experiments. I know that people have shot large particles into tantala aerogel, and it's worked well, but we have no experience at all with small particles. So that's a great idea, Mike.
And what is it that Steve's going to do that's going to get rid of these surface features and these cracks? Is it he's going to be more of a artist in his design here?
No, it's Well, I think the main thing is that it turns out that to make the surfaces of the aerogel flat, he laid down glass cover slips to make that aerogel flat. And I think the lesson from Stardust at home and from our experience with Stardust before or up to now is that we can tolerate having surfaces that are not flat, because they'll still be flat on a microscopic scale. We wouldn't notice it really. And even if it's not, as the Stardust at home dusters know, we can cope with surfaces that are tilted. It's not a problem. And so I think what we would do is to not use those glass covers, which are possibly what are causing most of the surface features and cracks. But we would have to do some experiments. He's always used cover slips or cover glasses, and so we don't really have much experience with not doing that. So I think it'll be worth doing for sure.
Well, he hasn't run any tests and come up with a solution yet. He has some ideas on what might work.
Right.
Okay.
Right. Another possibility, which we've done before, and this works, is to cast an aerogel tile, and you don't care what its surface looks like, and then you you let that harden. You don't extract the solvent, but you let it gel. Then you pour on a second layer, which is very thin, like only a millimeter or two thick. And he's done that before for us, so that's worked very well. And the surface does look better. So that may be a way to go. But a lot of these things it's a black art, black magic. You just have to try things and see what works.
Yeah, alchemy was the word I was looking for earlier. What if he created it as usual and then somehow sort of just shaved off all the edges so they're nice and clean? Probably worse, but I was
shaving off.
That
sounds simple.
Yeah,
that sounds simple, but we know very well that it's very hard to work with aerogel.
It gets in the eyes and everywhere.
Yeah, well, no, but it just doesn't cut cleanly.
Yeah.
Yes, whenever you try to cut it.
All right. Well, while we have the opportunity, any other questions for Andrew here? What about Augusto? Anything on your mind?
Maybe Tom, Mike, and me can go into the space for pick with our hands some interstellar particle.
I think we need an interpreter.
Sorry.
I think Augusto wants to sign up for the space program.
Oh, yes. Right. Yes. Oh, if you haven't seen, so I don't know if it's showing in Italy, but if you haven't seen Apollo 11, the movie, yeah, it's fantastic. Just fantastic. What's great about it is that every single thing in it is original. There's no there's no modern narration or explanation or anything. It's all original and a lot of new stuff. I mean, things that I've never seen before. Amazing. Just fantastic.
So has some of it been restored and we get high def versions and things of that nature?
I don't know the details, but they're just spectacular, just amazing images. Yeah. And for those of us who, are of a certain age, some will be nostalgic, will recognize the voice of Walter Cronkite and, kind of gives you goosebumps. It did to me. So.
All right. Well, if there are no more questions, then I guess we'll wrap up. And once again, thank you, Andrew, for your time. We know it's precious, and we very, very much appreciate everything you do for the team and for keeping us up to date. What can we expect in the future? Might we get Anna back with an update on her project, or maybe
possibly? Yeah. It also is possible that we can get when Brad is a little bit further along with his candidates, that we could bring him back on. That was I thought that was terrific. very useful. So,
Great. Yeah, and you said they're both, he and Rhonda are going to be here at the lab.
at least Rhonda. I'm not sure about Brad, but
Okay.
Rhonda will be here.
Maybe
Mid-April.
sneak her on camera for a little bit.
Maybe. That'd be good. Yeah.
All right. Well, thank you, Dusters, for your time. Mike, Augusto, we appreciate all the work, and we'll talk to you in a month.
All righty.
Bye-bye.
Then.
Good night.
Bye.
Bye.
Wow.